SunSquare is the inventor of the retractable motor-driven sunsail and specialists in kinetic architecture. Since 1994, when Gerald Wurz installed the first sunsail prototype on a rooftop terrace in Vienna, our goal has been to provide large-scale, generous textile architecture while transferring the minimum amount of stress into buildings and foundations. This idea led to a patent in 1995, but SunSquare was working in no man's land. We needed to determine all the associated parameters, including how large the units could be, how asymmetrical sail cloths could be, which materials could be used, and so forth. This process has continued until today. For example, in 2009, we installed a rectangular unit, which you see here, with a surface area of 70 square meters when extended. One question with units like this is, how can we make them wind stable, as wind gusts can occur unexpectedly? Here, only the installation of a spring element between the drive unit and the sail ends can compensate for the induced forces and minimize their impact on the supports. You can see that through this compensation, only 70-kilogram loads are transferred to the supports. This spring element can either be in its simplest form, an open stainless steel spring, or the new pneumatic spring, which you can see here. The second safety measure taken with this unit, as it's motor-driven, is of course a wind sensor, which causes the sail to automatically retract when wind speeds exceed 40 kilometers per hour, preventing the shaft from being exposed to these wind stresses. Naturally, we had to develop a large variety of fastening elements for this system, some of which are quite austere. For example, this redirecting pulley, or a bracket to be used at the sail ends to provide a more stable fastening. We've also had to develop spacers in order to span insulation, ground supports which could be installed on insulated rooftops, ways to work around pre-existing components on site with custom parts, or measures we could take on site with the architect in order to be able to install it all, as seen here where an 8-meter support was set before the structure. One result of all this is our newest tensioning unit, seen here, which reduces the cabling in front of the building and provides visual clarity. Another important quality is SunSquare's strength in historically protected situations, a result of our ability to work with minimalistic fastening elements on historic facades, as seen here at Palmenhaus in Vienna, a 5-sail installation where the individual units provide a lovely rhythm in front of the structure. SunSquare works in cooperation with 30 dealers globally, for example our partner in Istanbul, who realized the 12-sail installation on the 12th floor, which you see here. This really is the highest art of sunsail construction, to bring these 12 sails into harmony while working in such an exposed environment. Projects like this require specially trained personnel in order to install effectively at these heights, as was also the case with the Unica Tower, an interior installation composed of 5 sails. This project was actually an early stage in the development of the pneumatic tensioning system, as here all of the drives had to be connected to the same point on the wall and could not introduce any vibration into the rigs. Also very important to us, of course, is the BMW World project, an 8-sail installation in a very westerly orientation, which means that this installation had to be severely angled outward for protection against the western sun, causing the installation to have a strong effect on the overall design of the facade, which of course led to a number of collaborative discussions with the architect. A terrific project, which has not yet been realized, is Porto Senso with Jean Nouvel, a 300-unit installation in an olive grove planned for very small sails which would snake along the natural facade. Here we've been involved with the architect in exploring new materials, which resulted in the decision to exclusively use galvanized steel elements to integrate with and highlight the character of the existing materials. Additionally, the project led to the conception of free-floating shafts. Another development project was in Kärntnerstrasse in Vienna, where long 15-meter by 3-meter sun protection was needed. As this was clearly not possible with triangular sailcloths, we developed rectangular installations, as you can see here at the Lower Austria State Museum. This museum project also contains the first instance of extruded aluminum supports in conjunction with a rectangular sail, which provides a completely new look. Another nice project, this one in Slovenia, is in front of a facade dating from the 1970s. This is a hybrid construction, a combination of triangular and rectangular forms, which needed to provide 70 square meters of both sun and rain protection. This next project is the Mega Sunsail project, a 700-sail installation which was unfortunately never executed. What you see here is a feasibility study, and what this study concerns is how producible sails in the required form actually are, as there were more than enough structural components in the way. One requirement was that this installation automatically retract at 90 kilometers per hour, and this was not technologically realizable. What was realizable, however, was this ship project. A 4-unit installation was planned here, which not only featured our new rectangular sail form, but also needed to fold down to the deck automatically, as the cruise ship occasionally needed to clear low bridges. It was also required to raise automatically, as the captain's area is also hydraulically controlled. As shown here, we sorted it all out, which was a challenge, as our first opportunity to tune this installation was on site, as there are so many kinetic processes at work here simultaneously that it was simply too complicated to be able to calculate everything beforehand. But we got it done, and we believe that these types of projects are the ones for which SunSquare will need to provide solutions in the future.